Okay, now, yesterday I did this. I did displacement, velocity, and acceleration. Okay? Velocity is actually when you differentiate what? The displacement. And acceleration is when you differentiate what? The velocity. Okay? So, can you see that this one is actually d2s dt squared? Differentiate 2 times, right? Okay? This is where I have stopped yesterday. And I have gone through example 1 on page 147 yesterday. Am I right to say that? Correct. Okay, now, today I'm going to go on to example 2 and then I will start the homework for 18.1 review. I know yesterday I said I want to continue, right? I think whether not enough time. Better halfway I don't like. Okay, now let's look at example 2 now. Now don't talk, kinematics is something that you need to visualize. Okay, I need to understand, okay? Now, a particle moves in a straight line so that at time t seconds after leaving a fixed point O, its displacement s meters is given by this. So I have this. Okay, this is the displacement function. Okay, now next, part 1. Find the value of t when the particle first returns to O. Now, this is O, right? This thing moves and then it must return to O. Now, do you agree that when it returns to O, S is 0? Correct. That means there's no displacement. Everybody okay? So, first part, when S is 0, I will have, am I right? Correct. Now, I divide both sides by 2, so I have this. Am I right? Do you agree that if I have this, I will have this? Talking to you. Are we okay here? Are we okay here? Then I want to ask a question. Will e to the power of negative t ever be 0? No, it will never be 0. Everybody clear? It will never be 0. So, since it will never be 0, right? What will happen? What will happen? The answers is rejected, right? Correct. This one will not exist. Or you say not applicable also can. So, I'm left with this one, right? Correct. Sign of this is 0. Okay? Now, I want you to know the sign term. Sign term is like that, right? So this is 0, pi over 2, then this is what? Pi, 3 pi over 2, then 2 pi, right? When is it 0? When it's what? When 60 is what? 0, pi, and 2 pi, right? But the question says what? Let's take a look at the question again. When the particle first returns to 0, so it cannot be 0, because if it's 0, t will be 0, then pi over 6, then what is this? Pi over 3, right? 2 pi over 6, okay. Better don't like that. Some people don't understand what I'm talking about. 2 pi over 6, right? That means the displacement is 0 when t is 0, pi over 6, all this. That means what does it mean? That means it will go like that. Can you see it? Can you see it? But we cannot take this one because it's the initial position. So when is the first time? This one. This is the second time. Do you understand? So the question says, what is that? Find the value of t when the particle first returns to 0. So t must be equal to pi over 6. Are we clear? Are we clear? Yes or no? Okay, now if you go higher level, right, if the thing goes down, like that, it's actually simple harmonic motion. It's like a spring like that. Okay? Alright, now, next one. Part 2. Sorry. The particle first comes to instantaneous rest at point A. Find the value of t at A. Now, I told you already, when it is at rest, what is 0? This day I say already. When it's at rest, what is 0? Velocity is 0, okay? Now, are we having the velocity function yet? No, right? So we know this, s equals to 2e minus t sine 6t. Now, do you agree I must differentiate this function? So what do I write? ds dt, which will give me v, right? Okay. Now, I fix this. I differentiate this. Become what? Cosine 6t times 6, right? Okay. Plus sine 6t. What do I have here? e2 minus t. I will have a negative, correct? Yes or no? Okay, so what's the answer? 12e minus t cosine 6t minus 2e minus t sine 6t, right? Correct? Yes or no? Okay, what is a common factor that I can take out for both? That's why I just tell you to take out the maximum, so don't take out, right? Okay? Of course, you can don't take out here. I can say when v is 0, right? Agree, class? Okay, when v is 0, I will have 12e minus t cosine 6t minus 2e minus t sine 6t equals to 0. Am I right? Correct. Now, a common factor correct? Yes or no? Yes or no? Yes, huh? Now, same thing, I will have this. Correct? Now, can this ever be 0? No, this one will be what? Rejected, right? Okay? Now, then I have the other side. Okay? I have the other side. Now, I'm going to do this. 6 cosine 6t is sine 6t, right? Correct. I'm going to divide both sides by cosine to change it to what? Tangent. Okay, if I divide by cosine 6t, I'll have 6, right? Then this one will be tangent 6t. Agree? Okay, now continuing here. That means tangent 6t equals to 6. Okay, what is the basic angle? All of you press a calculator. Give me in radians. It must be in radians. What is the basic angle? Okay. Like this, you learn it. Change it to radians. Alright. This is a 1.4056. Agree? Okay? Now, positive, but the question say what? Look at the question. The particle first comes to rest though. So the first angle will do. No need to go and do so many. Do you understand? Okay? So 6t will be equals to 1.4056. Repeat it. What will be t? 1.4056 over 6, right? Okay, so let's take a look. 1.4056 divided by 6. I will get a 0.23426, which will be 0.234. Is that clear? Is that clear? So the particle will first come to rest when t is 0.234. Understand? Okay? Alright, now next part. Find the acceleration of the particle at A. Now, class, how will you get acceleration? Acceleration is what? Good. Acceleration is dv over dt, right? Which means I must differentiate this guy, right? Everybody clear? I must differentiate this guy, but can you see this guy is actually quite difficult to differentiate because there are a lot of terms here. Okay? Can I do it one by one? Can I do it one by one? I do this one first, can? Or maybe I should do this one to be better. Wait. V equals to that is easier. Can you see only 2 terms? Can you see it now? Okay, I'm going to differentiate now. Can you see this is not a challenge of whatever. It's a challenge of your differentiation plus your integral. You You understand what I'm talking about? Okay? So, what do? I fix this guy, right? I fix this guy. I differentiate this guy. Come on. Negative 6, right? Sine 6t times 6, right? Then minus what? Cosine 6t times 6, right? Everybody okay? I haven't finished yet, you know. Some people after here will think they're finished already, haven't. So how? Plus what? Plus this one, right? Then I differentiate the other one. What does it give me? Correct? Negative 2e minus t, right? Yes or no? You must do it slowly, if not you'll become wrong. Everybody okay? Now I'm going to simplify this. All of you look. This one will become negative 36 sine 6t minus 6 cosine 6t plus, sorry, I can put a minus. 6 cosine 6t minus sine 6t, right? Okay? Now, I can take out a common factor, which is what? E to the power, 2e to the power of minus t. Okay? Now all of you look up. If I take this out, this one only left this one out, right? Alright, so I will have, okay? Then I will have to minus this one, right? Alright, so what do I get? 6 cosine 6t. What is this? Minus sine 6t. Wait, I made a mistake. Did I make a mistake? So far I cannot see any mistake. I don't know whether there's a mistake. Okay, come, let's take a look here. 2e minus t minus 36 sine 6t minus 6 cosine 6t minus 6 cosine 6t plus sine 6t. Am I right? Minus then plus, correct? Okay, so finally, our line is safe. What is this? What is this? Minus 36 plus 1. So, minus 35. Then, minus 6, minus 6. What is that? Minus 12. Alright now. This will be my acceleration function. Agree or not? Acceleration function. Okay? Now, look at the question here. Some people after the differentiating forget what's the question. Can we look at the question now? Find the acceleration of the particle at A. Now, just now at A, right? My t is what? 0.234. Forget. Wait, let me just do it again. Shift tangent 6. 1.4056. 1.4056 divided by 6. 0.23426, right? That's now?
Yes.
Correct? Yeah. 23426. So, this is my A function. Correct? So, I will use another color because the whole board is full of rubbish now. So, when t is 0.23426, now how come I must use this? I cannot use 0.234. Working must be 5 from k, remember? Okay, so I will plug in. A will be 2e minus 0.23426 minus 35 sine 6 times 0.23426 minus 12 cosine 6 times 0.23426. You understand? Don't speak, Brian. Sleeping since Tuesday or Monday, you know. Well, wait, the whole week still sleeping. I want all to key in now and see if you get the answer. Key in your calculator now. to find truncate first. I don't want the answer straight. What's the answer? Negative what? 57.1. 749. So this will be a negative 57 point. Oh, point what? 0.7. Am I right? So the acceleration will be 57.7 meter per second squared. Okay? Now, at this juncture, I want to confirm something because you told me the whole class don't take physics, right? I'm going to say something here. Velocity is in meter per second, you know, right? So it's also meter second minus 1, you know, right? Per second. Actually, this is meter per second. So I write it in index form, meter s minus 1. Can you see? Because this is, okay? Now, this is velocity, yeah? What about acceleration? Is meter per second squared. Because it's the rate of change of velocity, velocity is meter per second. So again per second means two times. So actually I can write it as meter like that also. Understand now? Because you tell me you're not physics student, so you might not have seen this before. You understand what I'm talking about? So it's equivalent. Understand? It's units. Everybody clear? Can or cannot? Can, So repeat, velocity is meter per second, acceleration is meter per second square. It can also be written in this manner. Okay? You just think of it as indices, n over s. So s is negative 1. Then this is m over s squared, so s is negative 2. Understand? Okay? Alright. So I have finished this part already and the time is just nice. Now I'm going to give homework. I think you'll be very pleased with me today. Because I'm also very pleased that I'm giving this kind of homework. Okay, what's the number on the content page now? 20 or 21? 23? 30?
21 now?
21 okay, very good. 21. Today's date is also 21. Wow. Very good. I'm going to buy 40, 2121. Then if I strike first prize, right, I'll resign. I refuse to integrate anymore. I'm too tired. Do you understand? Okay? Now, so exercise 18.1. Just like kinematics. Now, I want it on full scale. Question 2, question 6, question 8, question 12. And 13. Very good, right? 1, 2, 3, 4, 5 only a what? You know this is the best ever? Do you agree it's the best ever? Okay? Any WA tomorrow?
No.
Any WA tomorrow? No. By tomorrow. Okay. Off the camera now.